of great faces, but I know it's been 1 hour since you had lunch, so let's have some exercise, okay? I want all of you to stand up. It's good to exercise 1 hour after eating, right? Spread your hands like this. Up, join them. Up. Faster, faster, faster. Round of applause, everybody. Now please be seated. Actually, I had a sentence written by Khushbu for me to greet you all in Gujarati. I don't know, I haven't memorized it. So please assume that I'm speaking Gujarati. Hi everyone, my name is Nida Shaikh and I'm a software engineer at Content Stack. And when I'm not being a software engineer at Content Stack, I am a full-time cat cuddler. Any cat lovers out here? Cat lovers? Very less. Any dog lovers? Yeah, I love dogs too. So, yeah, full-time animal cuddler rather, I'd say. And I like to explore specialty coffee. I like to read books sometimes. And just like every other software engineer, I like to travel as well. So I'd like to start by telling you a story, okay? Do you all know about this game? Anybody knows this game? It's okay, I did not know about this game either, like until a few months ago. So my younger sister was playing this game. Basically what this is a restaurant management game. What you do is, you are the sole person who is running the entire restaurant. You take the orders from the customer, you fry the fries, and you make the sandwich. You place it in a plate, and then you give it to the right customer. So you are the one-man show, the manager of a restaurant. So I wanted to play it. It had great graphics, so I wanted to play it. So I asked my sister to go fetch me a glass of water, because since she's a younger sibling, I have to make her get up and go somewhere for me to actually use the laptop. So I asked her to go. And I started playing. So I got my first customer. I took the order for the first sandwich. And then I went into the kitchen and I started preparing it. So I was frying the fries, and then I was waiting while the sandwich was grilling. So then my sister comes from the kitchen with a glass of water in her hand. And she says, "Hey, what are you doing? Why aren't you going to the counter? There might be so many customers waiting there, and if you don't go, they might leave. Go, go, go." And then I went to the counter, and there were already 3 customers waiting. And as you can see, the first customer, she's already very, very angry at me because I did not give her my time of the day. So that day, there's one thing that I realized, is that I am not cut out to run a restaurant. And another thing is that, what if this happens in real life? Well, there's still a human touch involved. So the waiter or the manager might come and they could apologize to you. But what if this was your website? You click a button, you expect something to happen, but then nothing happens. It just hangs and the page becomes unresponsive. What then? Would you stay onto that website? Would you? I can't hear you. Would you? Obviously. So 100 millisecond, that is a threshold for human perception. If you want your users to stay on your website and actually feel that their actions are resulting into something, 100 millisecond is the response time for that. And if you take anything longer than that, then the usage of loaders, progress bars, they help to intimate the user that something is happening in the background. But what if you click a button and you cannot do anything else? You cannot even select any text, expand or collapse any other sections of your website. Nothing. It just hangs. Won't you feel something like this? I have actually done that. You know what happens when you click a button and nothing is happening, so you keep clicking on it until something happens. And then you remember in the Windows, there was this refresh. You used to keep refreshing it till your system comes back. So yeah, that's what one does when nothing works. Why does this happen? Because JavaScript is single-threaded. Now, our web applications, they run on JavaScript. The Chrome and all of the all of the browsers, they run on JavaScript engines. And JavaScript itself is a single thread. What does it mean? It has just one main thread, which will run the tasks. So when you add any of the tasks, and it will run, complete, and then leave the thread. But then what happens if you put an expensive task, a task that takes very, very long time? What will happen then? The main thread is going to get blocked. And then you can't do anything else. Even your rendering can stop at times. So that is when your main thread gets blocked, and you will get support tickets like this. And this has happened, right? This is a real ticket if you can check on community, a Google community. So I don't want to talk about JavaScript event loops, because there are a lot of YouTubers who have already covered all of this at length. So let's skip that. We all know that JavaScript is a high-level, single-threaded, garbage-collected, interpreted, prototype-based, multi-paradigm dynamic language with a long, non-blocking event loop. We all know that, right? But what if we could change just one word out of the definition of JavaScript? What if we could make JavaScript from single-threaded to multi-threaded? Have JavaScript do more than one task at a time. Now you'd say that, Nida, JavaScript can already do more than one task at a time, right? Have you ever heard of concurrency? Yes, I have heard of concurrency, but here I'm talking about parallelism. There's a difference there. What do I mean by concurrency? Concurrency means that multiple tasks start, run, and end at overlapping time periods with no specific order. Now, CPU's context switching is so fast that you feel that everything is running parallel. It's all happening at the same time. But that's not the case. That's not what happens. Now, parallelism, on the other hand, the tasks actually happen at the same time, but running on a separate thread. Understood? So when there is a separate thread, an expensive computation is running on a separate thread, the main thread that runs your actual business logic of your application remains unblocked and available for any other interactions that your user needs to perform. So that's a win, right? Let me just quickly show you how the main thread gets blocked. So all the animal lovers, maybe cat lovers and dog lovers, you might probably like my demo. So this is an application that it's a POC basically. So we were building an application that used to add presets to an image. What is a preset? It's basically a filter. Now, can somebody tell me what exactly a filter does to an image? When you apply any filter, what does it do? It changes how the image looks like in the basis of colors, or maybe how the exposure is, or it changes the way it looks. Now, how does an application change the way the image looks? It basically changes and manipulates every pixel of that image, right? So that is how you manipulate an image. That is an expensive computation, don't you think? You upload a 7 MB image on a web application. Now, how many pixels might there be in a 7 MB image? Probably millions, right? Depends on the resolution of your picture. It's going to be a lot of pixels. Now, manipulating all of those pixels to apply a preset to it, that is an expensive computation. So we were building a web application that adds a lot of filters to your image. So what was happening is, I'll show you. I will quickly run the POC. And this is a good thing that's happening. I will show you the responsiveness of this, because if you see, as I move my cursor, there's a cat that's following me. Okay, so you can see that my web application is responsive, right? So I'll choose an image. As you can see, this is just 1.9 MB, okay? And I'll upload it. And as you see, everything else is working. I can hover on this, write some review. This is nice. Let me show you what happens when I click on apply heavy filter. Everything is stopped for a second, right? It stopped. Did you see that it stopped? So my processor is an M3 processor, which is one of the fastest ones. What happens if your processor is really slow? What happens if your mobile devices are really slow? Obviously, you need to cater to all of the users of your application, right? Let me just quickly show you. If I throttle this to 4x slower, and then I apply the filter. See? I can't do anything else. Even my cat is going haywire. Nothing. And now it's working. So see, this is how your main thread actually gets blocked. So JavaScript, it's not its fault. It's my fault that I didn't put proper optimizations. I didn't think about the performance. I didn't think about the way that it can be improved in such a way that my user is not blocked for performing any of the tasks. So let's just come back. So if this happens, the thing that I just showed, if this happens in your real world applications, yeah. And if your application is free, then your users are going to say that, all right, I'm heading out. But if your application is paid, they might never ever renew with you again. It's a real problem, right? So what I think is that the main thread of JavaScript is overworked and underpaid. And what is the solution to that? One of the solutions to that is called web workers. Now what web workers do is that they're a simple means for you to run scripts as background tasks. Okay, so if there is any heavy computation, you spin off a thread. You offload that expensive computation to that thread, and then you make your main thread available for every other operation that your user wants to perform. So that is what web workers are. Any doubts about what they are? I think I've been pretty clear. So let's just dive into how you can start using it. So there's your main thread, your main application, and you create a worker thread by using the worker constructor. So when you do that, there is a thread that is created. You get a reference to that thread. Now you have two threads, right? They're running parallel to each other. How do you communicate? Right? They are running in separate contexts. Your worker thread has got nothing to do with your application. It will have no data from your application, nothing. Whatever you send using the post message API from the main thread to the worker thread is the only data that your worker thread is going to have. So all of your variables, all of the objects that you have created, everything that has to be sent through the post message API to the worker thread, and then it can perform their operations. And after you have completed all of the computations, what you can do is, and what you have to do is, you have to terminate the thread. Now, why do we have to terminate the thread? Because we're spinning off a new resource in your user's machine. So it is our responsibility to safely end that usage, okay? Because then it will create a memory overhead. So why don't we talk about a little bit how the web workers talk to the window? Now I said about the post message API. This is simple, right? We have always used post message API like this. We have sent a message. This is called structured cloning. So what happens is when you send a message this way, there is a copy of that object that is created in the worker thread. So we have an object in the main thread, and a copy gets created in the worker thread. It's the same, but there's a copy. But what happens if your object is like really, really large? Okay, it's a big data set, or it's a big image, or it's a big video. How are you going to process that? Because then it will create two copies of the same thing, right? And that will create a memory overhead. Your RAM probably won't be able to take it. So there is another way of sharing data between the threads that is called transferable objects. Now what transferable objects do is that when you pass your object from the main thread to the worker thread, it does not copy it. It literally transfers the context of the object. So when you have passed it, you can no longer use it in the main thread. So at a time, only one instance of that object remains, and then it is an optimized way of transferring objects from thread to thread. That's how it works. let's talk about some caveats of using web workers, all right? Uh, this is not a silver bullet, right? You can't do everything with web workers. This is not like one solution that you make everything multi-threaded in JavaScript. That's not how it works. You cannot manipulate DOM, which is a big problem because everything that you do on front end, you need to put it on the DOM. At the end of the day, you need to display it. But from worker threads, you cannot manipulate the DOM. You have to find some other way to do that. We'll see that, how we can do it. Another thing, we cannot access the global document or the global window object. You know, with the document object, how you can access HTML elements and you can create HTML elements. Since you cannot manipulate the DOM, in the worker thread, you cannot even access the document or the window objects because the context is different. It's not related to your browser. Okay, it's not related to in any way your web application. So these objects are not available in the web worker. But yeah, another thing, you cannot access local storage or session storage. Now, what is local storage and session storage? I think Nisha touched upon it a little bit. It's the database inside of the browser, like the cookies that you save or session information, your login information, where once you come to a website and you see yourself logged in, how do you think that happens? That happens due to the in-browser memory storage. So that is one thing that you cannot access in your web workers. But you can access a lot of other web APIs in web workers like fetch, encoding, file system, IndexedDB, off-screen canvas, WebSockets, and a lot more. Even WASM. Varun's talk covered brilliantly about what WASM is and how you can use LLMs and SLMs in WASM. And you can use the WASM WebAssembly in web workers as well. So that is an added performance bonus. Now let's get our hands dirty and dive into the code of it, okay? I don't think you will be able to see me. So it's good actually, you can look at the code. So let's go. So I had this button, right? Let's add one more button, which is called apply filter with web worker. Okay, it's giving me an error because I have not added the on-click event. So what do we have to do? So do you remember that diagram that we built? We instantiate a web worker, then we pass messages using post message, and then we safely terminate it. That's exactly what we are going to do. Okay, so let's go through the traditional way. In the apply filter function, what I was doing is I was applying a heavy filter. Can you see my screen? Wait. Now is it visible? So on click, what I was doing, I was loading it into an image. This will create an image data. And I was applying a very heavy filter. Now what does this very heavy filter is? It just paints the image on the canvas. So canvas is an element that we use when we have to manipulate every pixel of an image. That is how, that's the best way you can use. By the way, I'm using React in a Google conference. I hope the security is not going to throw me. I'm not an Angular user, I'm a React user. But the thing is that this is JavaScript agnostic. You can use web workers in any JavaScript framework, okay? React, Vue, Remix, Angular, anything that you want. So let's put that aside. So this is all the things that I was doing. I was applying a Gaussian blur. I was applying a vignette, applying a color tint, and I was enhancing the contrast. And what these functions do is that they do a lot of things. They traverse through every pixel of every image. They manipulate it, and that's how it gets done. And that is why it is so janky. It does not render fast. We'll do the exact same thing using web workers. How are we going to do that? Let's create an on-click. Oh, thanks, code complete. I'm going to use it. That's exactly what I wanted to do. So nice. Yeah, I'm also, my heart is clapping for the AI. Yeah, so what I'm going to do, I'll create the image, then I'll do an image on load. Yeah, but now the AI is not telling me the right answer. This is not what I want, okay? So what I'm going to do is when I load the image, I want to pass it to, first I need to create an image bitmap. So this is a little technical. I will need to create a bitmap because the bitmap is something that you can actually pass through the web worker. Image bitmap. Image. Sorry, I'm a little nervous, you guys. Async. Okay. I'll pass the image bitmap. And then I will not use the auto code complete, and I will, oh, it's one thing that I missed. Now when we click on the button, we need to create a web worker, right? So let's create a web worker when we click on the button. So this is all right. So let's do a const image worker register web worker. Now let's actually create this function. And how we create a web worker is, of course, we use that worker constructor, new worker, and we pass the relative URL. We'll pass the relative URL. So I'm using Vite as a bundler. So what Vite asks you is to pass a relative URL to it so that when we actually create a bundle out of it, it performs proper optimization on their end. So I have this file which is called image filter worker. Thanks. Yeah, this is how we do. We create a web worker like this, and we will return this instance. Here, I will get that instance, image worker, and then after creating that image bitmap, I'm going to post the message, image worker.post message. And I will use transferable object. How do you use a transferable object? If you see, there's a transfer written over here. Here. This is how you pass the transferable object. This is done. This is what has happened in the main. Now I will go to the worker function. Here in the worker file, I have already written these functions. Now you might ask me that why aren't we reusing these functions? I think we've already written it, right, in our main app. Any answer to this? Why are we rewriting it again in this file? Because there's a different context. You cannot access anything on your web application in your web worker because there's a different context altogether. So we need to write our functions again, whatever we need to use here. And let's accept the message here. We'll post the message and we'll accept the message. Event. And we'll const image bitmap. We're passing the image bitmap, right? So we'll get it from event.data. Yes. Now we are going to use something called as off-screen canvas. Do you know the canvas element? Canvas element that gets rendered on the DOM. But here you cannot access the DOM. So how will you paint your images? How will you manipulate your images? That can be done using off-screen canvas. Now off-screen canvas is a really nice tool. What it does is it's decoupling the canvas from the DOM. So you can perform everything that a canvas can, but you don't need to render it, and you can do anything. So that is supported in web workers. So if you need to perform any actions in a canvas, you can use an off-screen canvas. So let's create an off-screen canvas. And we will pass the width and height of the image bitmap. Then we'll create a context, a rendering context. and we will draw the image. So when we draw the image, we give it 0, 0 as coordinates so that it can start drawing from the top left corner of the canvas. So once we've done that, now we'll get the image, const image data from the canvas, we'll get it. And now we will perform all of this. So in the traditional way, if you see, I have done all of these things. Now we'll do the same things here. In the web worker. Okay, it's a constant, so I'll just use let. And I will draw the image on the context, put image data, and I'll convert it into a blob. Blob is binary large object, which you can convert your images to blobs and you can transfer it from one context to another. So it's a more efficient way of doing that. Image blob, convert to blob, and then we will pass the blob to the main thread. Let's not use transferable object here. Okay. This is doing the exact same thing as the traditional way does. Now let's test it. Now this is the message that I'm posting. I need to receive it in the main thread, right? I've just created the worker. Now when the thread is going to send a message to the main thread, I need to receive it. So let's come back to our main thread. In our register web worker where we have created the worker, we'll create a event listener for the worker. We will not directly set it. We will need to transfer it to an object. Oh, thanks, code complete. Yeah, that's exactly what I want to do. So I receive the image blob from my web worker. I create an object URL. So this is the URL that I will append in my image tag. And then I set it as a state, the React state. Now where is the error coming from? Oh, there's, okay. Yeah. Let's see. Let's test whether this is working or not. So I don't see any errors. I've registered the web worker. Missed an important thing again. After we have received the message and the work of the web worker is done, what is the most important thing that we need to do? What is it? I can hear. Can you be louder? Close the web worker. So after that is done, after I receive it, I will do worker.terminate. That is how it is. And let's see. First we'll test with the traditional way, and we'll even record our performance. Okay, so let's start with the performance recording. I'll choose the file and I'll click on apply heavy filter. Nothing is happening. Sad. Now it's working. Let's stop and let's see what the profile has to say. See, if I open the main, can you see it? Sorry, here. How long has it taken? It's taken 11 seconds, 11.8 seconds, that's almost 12 seconds to do this. And during this 11 seconds, the user will not be able to do anything else. Now let's apply the same filter using web workers. We will record it again and apply filter with web workers. Now we can do everything. I think there is an error in the console. Obviously, what kind of a demo runs in the first try, right? So let's see what this is. Okay, this There's a promise that I did not await. Yes, this was the promise. So converting to blob is an asynchronous function. I will async await, and I think the create object URL is also async. Let's see if it's asynchronous or not. Anyway, I don't remember. And let's apply. Yeah, there's no problem. So quick. And this was on the 4x slowdown as well, I think. Let's check the performance metrics of this. Oh, oops, sorry. Let's record it again. My bad, you guys. I'll record this, choose file. Yup. Super cool. It's still a little, there's still scope for optimization, but now this task has just taken 49.49, 115 milliseconds. It's just processing. Now, if we check the worker thread, there we'll see the big, sorry, where is it? Yeah, here. Now, this is the functionality of the worker thread. Now, this has taken only 2.29 seconds, which is still much better than the 11.8 seconds. Right? Why did this optimization happen? Because of off-screen canvas. Because it decouples from the DOM. So it's much faster. It's 33% faster as per the documentation, but I can see it's much faster in action. So yeah, that was it, you guys. Now, no, my talk is not over. My talk is not over. I see that you all are very eager to push me out of the stage. I will take just 4 more minutes of yours, and then I'll just leave. So you can have whatever tea, coffee that you like. OK. So where can you use web workers? So as I've been saying this in my entire presentation, wherever there is something of heavy computation, you can use web workers there. Now, I used it for image manipulation. Suppose you're building a web game where you have to calculate the physics of the game at every single frame. There you can use web workers. Anywhere, and especially when you have to deal with low-end devices and you think that it may not be able to process things so quickly, there you can use web workers. Another is you can use it for data aggregation. Now, I think that data aggregation is best done at the back end, but if you are unlucky and you have to filter or sort or transform a list of like thousands and millions of entries on the front end, there maybe you can use web workers. Another of my favorite application of web workers is using it for third-party scripts. Now, what are third-party scripts? Third-party scripts are basically all of the scripts that you use on your website, which is not the part of your business logic, like your ad services, like A and B testing, like your analytics. That is a secondary part, but you still need to include it in your application. So maybe that is where you can use web workers, where you provide it a sandbox environment away from your application, and it may not interfere with your proceedings of your application. So what I like to put it, so web workers is a little unconventional way of doing things on web, right? JavaScript itself is not it's not multi-threaded. We are using it separately for multi-threading by using web workers. So what I think is that web workers help you with stuff that you shouldn't be doing, but you're doing regardless. Well, it's not a silver bullet, as I said. It will not solve all of your performance problems, but you know, that's why we are here. Now, in my company at Content Stack, we believe that in engineering, there is no one right solution. But knowing all the best possible solution may lead you to a solution that you might need. So that is why you must attend such amazing conferences where you can learn from other people's experiences. And I'm so glad that all of you are here. I can see all of your attentive faces. Round of applause for yours, guys. And thank you so much for lending me your time. You can connect with me off the stage, or you can connect with me on socials. There's my LinkedIn and my Twitter over there. And again, thank you for being such a great audience. How do you say thank you in Gujarati? Aabhar. Ahmedabad. Thank you.